Okay, we're in section 8 of the notes, and this is basically a review on the polynomials. All right, so we covered the material. And again, I'm hoping you paid attention, not that you fully understand everything that's presented to you. Certainly, as we do examples, you'll know what the expectations are when we do examples. You should study this material, though. And furthermore, if lectures are not working for you, I do want to point out there's little tiny lectures in the side here, which may be better for you to do. All right. But again, that's up to you. You decide what works for you. All right. Your goal here is to learn the material sufficiently well that you're going to pass the exams and move forward. And that's what we want you to do. We want you to move forward. Okay. So where are we now at this point? We did the lecture. Hopefully understood what we presented to you. And now we need to reinforce what we've discussed by taking examples. You'll be given an opportunity after this to do examples on your own. And this is typical of the notes. So what does it say? Homework. There's examples for you to try. All right. But before you do that, we would like you to do the lecture material, then watch me do the examples at the board, the whiteboard. So I'm going to switch screens. Give me a moment to do so. Okay, we'll start with the examples. And again, we're in section 8. So let's take a look. And as I look at these problems over here, my goal is to do the problem. All right, so I'm looking at example number 1. And let's just take a look at this. I'm going to pull it. Nah, well, you know what? I'll do it right in front, right over here. And this is what I would recommend you do too, is have your notes out and you write on it. And what they would do P of -2. So what I'm going to recommend over here, if someone asks you to evaluate the polynomial where the variable is equal to -2, write it down. Write down P of -2. My suggestion, though, and it's very similar to the suggestion that you're given in math, 086 and 092, is to parenthesize the variables. So let me do that first. So I see -3. I see a variable x, and that's being squared. I just parenthesize the x. -2. I'll parenthesize that x, and then +6. And then you're going to plug in the value of the variable. In this case, it's -2. Now, some people are faster at this than others. Speed is not what we're looking for. We're looking for an answer, and we're looking for a correct answer. So what do you get here? -3. -2 squared is going to be 4. Now, this next that I'm going to do it, it's going to be minus a -4, which is +4. I'm going to keep working on it. This will be -12, +4, +6. I'm following the order of operations. Or if you add that together, you get -2. Now, do mistakes happen? Of course they do. So what are you going to do? Look at your answer and look at the answers that provided and make sure they're in agreement. All right. Let's do the next one. And next one says use vertical and horizontal format. I like horizontal format. And the reason that it's just my preference, but you may like vertical. So I want to just go through one at a time. I'm going to do horizontal first, and then I'll do vertical. So if you do horizontal, what I would do is just looking at the problem, I would just move left to right in the problem. And let me put on what I mean by that. I see 4x squared. I would scan left to right, and I see another one over there. I'm going to say if I did that, you're adding their coefficients together. These are like terms because they have the same variable part, which is x squared. I just add their coefficients together, and what would you get? You would get 0 x squareds. All right. I'm going to keep scanning it, and I go left to right. So -5x. Do I see any other? Well, I do. And what do they want me to do? They want to add 5x, right? So -5x plus 5x. Well, that's going to be 0x now. Let's keep scanning it left to right. I see a 6 plus a -13. Well, 6 plus -13 is going to be -7. Of course, what does this give us? -7. Because there are no x squareds and there's no x's. Again, look at the key to make sure you can agree with that. All right, I'm going to do the vertical format now. This is vertical. And by the way, I'm not going to say that you have to do it both ways, but you probably should see another way of doing it. And I'm going to write this down. And sometimes I use vertical because things get really complicated. Vertical does work nicely. So I'm gonna write this at 4x squared minus 5x plus 6. And what I'm gonna do is add that polynomial, which is minus 4x squared plus 5x minus 13. And if you were to do that, we get, well, 0x squared, 0 x's, and 6 minus 13 again is going to be what? Minus 4 minus 7. What do you get over here? The same answer. Not a surprise there. All right, let's do this one over here. And again, when I'm doing these things, there's two ways to do it. One is horizontally, which I prefer, and I'll do that one step at a time. So what do you see? 4x squared minus 2x squared. What would that give me? 2x squared. Let's keep moving. 7x minus a minus 6x would be 7x plus 6x, which is 13x. Going to keep moving left to right. Minus 5 minus a minus 7 is really minus 5 plus 7, which can be plus 2. I know what someone's going to say. Where's the answer? Turn the page. Right there. 2x squared plus 13x plus 2. Let me just go back and make sure you understand we've got that written down there. So I'm going to say 2x squared plus 13x plus 2. We're doing good. All right, number 4. Number 4 says we're given polynomials, and the polynomials we're given are P, and we're given R. P is a 4th degree polynomial with 3 terms. So it's trinomial 4th degree. R is a 5th degree polynomial, and there's 3 terms. It's trinomial. What do they want me to get? S of x. I'll write this over here. So S, whoops, let's go back to black ink. S of x is, well, let's write this down. It's P of x. Well, let's write this down. It's 3x4 minus 5x plus 5 plus R of x. And what's R of x? 2x5 minus 3x minus 8. Well, what I like to do is I like to go in order. And someone says, what do you mean order? Well, it's going to be order with the highest degree variable listed first. So let me write that down for you. And I only see one term that has an x5 in it. So what do I see? I see 2x5. All right, I'm going to clip that off, saying it's done. The next thing I want to do is, the next thing on my list is what's the next degree is the 4th degree variable. And I see that right here. And there's only one term that has a 4th degree in it. So what do I give there? Plus 3x4. That's done. And what am I looking for next? After 4 cubes, I don't see any cubes. I don't see any squares, but I do see a linear term. So minus 5x, that's degree 1, and minus 3x would be minus 8x. Last but not least, you have constants, 5 and a minus 8, which would give you a minus 3. We'll check the key later. What else do they want me to do? They want me to do T of x. I'll write this over here for you. And what's T of x? It's P of x minus R of x. Subtractions tend to be a little more complicated, but I can still write it down. What's P of x? 3x4 minus 5x plus 5. And here comes the problem for a lot of students. You're subtracting. What are you subtracting? The entire polynomial, which is 2x5 minus 3x minus 8. One step at a time. Well, still going to go in order. So I see subtract 2x5. I got that. Then I see plus 3x4. I see that. And then I see minus 5x minus a minus 3x is minus 5x plus 3x, which is minus 2x. Then I see 5 minus a minus 8, which is 5 plus 8, which is going to be 13. Again, we'll look at the key later. All right. Now, what do they want me to do? They want to do S of minus 1. I'll write this on the side for you. And they want me to do T of 2. All right, what do? Parenthesize the variable. And plug the value in, which is minus 1. What do we get here? Well, minus 1 to the 5th power is minus 1. 2 times minus 1 is minus 2. Minus 1 to the 4th power is 1, so this would be plus 3. 8 times minus 1 is minus 8, but minus 8 is plus 8. And I get minus 3 over here. If you did that, what do you get? Oh, just looking at it, it doesn't look that bad. It's 6. Now, do I make mistakes? All the time. So what I want to encourage you is if you make a mistake, try to rectify it. Let's put this one down. We'll look at the key later. Minus 2, parenthesize the variable. Again, parenthesize the variable. What goes in there? 2. What do you have there? 2 to the 5th power is 32. Yes, you'll be able to do that. So this is minus 64. 2 to the 4th power is 16, and 3 times 16 is 48. That would be minus 4 plus 13. And the numbers are kind of bigger, but minus 64 plus 68 is minus 16. Let's see, minus 20 plus 13 minus 7. All right, mistakes happen, by the way. You're going to find out when you start working, you're going to make mistakes. All right, you're going to make mistakes. Let's go back and see if we did okay. All right, let's see if we got S. I'm seeing it here. And I'm seeing here, what do I say? 2x5 plus 3x4 minus 8x minus 13. Do I see T of x? I see it right here. So it's minus 2x5 plus 3x4 minus 2x plus 13. We did good. Do I see S of minus 1? They say it's 6. I see it right over there. I'm in agreement with that. Do I see T of 2? Yes. I said it's minus 7. They said it's minus 7. All right, we did okay. All right, number 5. A little more complicated, bunch of questions there. They say the height h in feet of an object thrown upward above the ground can be modeled as follows. And they say this height, what do I mean by that? The height is a function of time. So this would describe where the object is at a given time t. Right, so the height is in feet, t is in seconds. And again, it's good to read and try to understand what you've read. They go on to say it's reasonable because they say, as we know, what goes up must come down. Well, I think that's reasonable. Let's see what happens. We'll take one step at a time. They say here, h is a function of time. Well, it's true. H is a function of time. How high is the object at 0 seconds? Let's write this down. Whoops. H at 0. Well, my recommendation, parenthesize the variable and plug in the number, which is 0. So what do you go over there? 6 plus 0 minus 0, which is 6. So what's the answer over here? Well, you have to understand that h is in feet, so the answer is actually 6 feet. Get your red pen out, see if you've done okay. You have. Okay, what's the next question? The next question is, how high is the object at 1 second? I just write it down, h at 1 second. Again, parenthesize the variable and plug it in. And what would you get over there? 6 plus 20 minus 16. If you did that, what would you get? You get 10, right? So what does that mean? 10 feet. Again, age is in feet. Look at the key, and we did okay. Now they go on to say, do you think the model is valid at 10 seconds? Well, I want to be honest with you. I think you can answer this without doing any work, but I still want to do the work for you. Now, what I mean by that, an object being thrown in the air, and you should realize it's really tough to get an object to stay in the air for 10 seconds. All right, particularly if the object is a free-falling object, it's not going to last 10 seconds. Let's go through it. So put h of 10 down. Again, if you can't remember the function, you look at it again. So it's 6, parenthesize the variable, plug in its value. And again, we'll explicitly state why it's not reasonable. This is going to be 6 plus 200 minus, this would be 1600, right? Let's keep going. And, certainly the way I do arithmetic, the way you do arithmetic might be a little bit different, but it doesn't really much matter to me. We should agree in arithmetic. So I just put down 6 minus 1400. And what's that going to be? Minus 1394. That's minus 1394 feet. I hope you realize that this is really not reasonable. I want to point out what's happening over here. An object is being thrown, it goes up, and then it comes back down. What hits the ground, the height would be 0. What am I saying? The thing has gone down really deep through the ground, and that's simply not reasonable. So I'm going to say this is not reasonable, all right? Not reasonable. It hits the ground well before 10 seconds, all right? So it's not reasonable. Let me go over the answer key and point this out to you. It says answer, no, this particular object will have hit the ground well before 10 seconds. Well before 10 seconds, all right? Now it says show that the object hit the ground at 1.5 seconds. Well, what does it mean to hit the ground? We're trying to show that h of 1.5 would be equal to 0. This is D. We're trying to show that. Now someone says, how would you do that? Well, I got to plug it in. I'm going to be honest with you. I don't like decimals, but that doesn't mean you can't like decimals. This is 3/2. Now, what do? Well, go back to the original function. I'll put out it's 6 plus 20t. I'll write this down for you. Then t is 3/2. Again, minus 16t squared. You know what? I realize this might look like it's going into another problem, so I'm going to erase it. And this happens to students who they get confused. And we're not trying to confuse anyone. All right, so let's just do this. And I'll write this over here. So h of 3/2 is 6 plus 20, parenthesize the variable, minus 16, parenthesize the variable squared. And what's the number? 3/2. And again, my hope is this is going to be equal to 0. Let's put it down. 6 plus, let me go through this for you. 2 goes into 2 once. It goes into 20 10 times. So what'd you get over there? Well, 10 times 3 is 30. Whoops. Minus, this is going to be tougher, 16 times 9/4. Well, here's the deal. 4 goes into 4 once. It goes into 16 4 times. Let's keep moving. So what do you get over here? Whoa, I did it again. 6 plus 30 minus, well, what's 4 times 9? 36. Well, 6 plus 30 is 36, and 36 minus 36 is 0. So we did. We showed it hit the ground. All right. And how was that? We just showed that at 3/2, we get a 0. All right. That's about it. There's not much else to say about that. The deal about this over here, you probably have to go back over that and make sure you understand what's been presented to you. But what you need to do now is do homework. You should spend a considerable amount of time in classroom just studying. I should say in classroom, but outside the classroom studying. Inside the classroom, you should be listening, paying attention, and try to make sense of what's presented to you. You certainly should take notes of that process as well. All right. Thank you for paying attention. See you soon.